week's STEM lesson. This week we will be discussing electric currents. Have you ever felt a shock, like we talked about last week? Maybe you had just walked across the carpet and touched something metal? How is this similar to lightning? Believe it or not, they are very similar. They are both discharges of static electricity. Lightning is static electricity on a huge scale. Lightning discharges a lot of electrical charge. It happens all at once, but unfortunately, this large discharge is not useful to us. It is so large and so fast that it cannot be controlled. You can't plug a toaster into a lightning bolt. For most devices, a much smaller amount of electric charge is needed. It must also be steady. It can't come all in one big jolt. That's why we can't run our homes off of lightning. Our homes need to have a steady and continuous supply of electric current. I'm sure you've all noticed the tall poles alongside the roads. Do you know what's on top of those poles? The top has wires that carry electric current. These wires carry electric current all the way to your home. But what is an electric current? Electric current is actually the flow of electrons. An electron is the outermost particle in an atom, and they have a negative charge. Electricity is the continuous flow of these particles. Electrons are able to move through wires. Their speed can even be measured. The unit of measurement we use for electric current or its speed is called an ampere. Amperes are often referred to as an amp. Electric current may flow in just one direction, or it can keep moving reversing direction. Direct current, or DC, flows in only one direction. Direct current is what's used in devices such as a flashlight. Alternating current, also called AC, flows in two directions. This is the type of current that flows into your home through wires. When you plug something into a wall socket, it is most likely an alternating current. Electric currents cannot go through empty space. Electricity needs something to flow through. Electricity cannot flow through all materials. Some materials resist the flow of electricity. Some materials let electricity pass through easily. Scientists classify these into two different groups. These groups are called conductors and insulators. Materials that allow electrons to flow freely are called electric conductors. Electricity is able to race through materials such as copper, aluminum, and steel because they are very good conductors. Materials that resist flow of electricity are called electric insulators. With an insulator, instead of racing, the current may travel in slow motion, if at all. Wood, rubber, and plastic are examples of electric insulators. You probably already know that electric wires are made of metal. They typically have a rubber plastic coating, but do you know why? Metals are good electric conductors, as we just mentioned. They offer little resistance to electricity. Most of the current can pass through the wire. Rubber and plastic are good insulators, and they offer a lot of resistance. These insulators do not allow much current to pass through. Electricity always seeks the path of least resistance. That is why all the current passes only through the metal wire. It does not pass through the rubber or plastic coating. The plastic coating on the wire is there for your safety. Now that's the end of the lesson today. Thank you for watching, and we will see you next week.